Okay, for our third example, we're going to look at this function, f of x equals x minus 2 over x squared plus 5x plus 6. We'll use that algorithm for curve sketching on this that we've done in the last two examples. And we'll see if this is any different than some of the other pictures. Every time we do one of these, we're going to learn more about them. So the more practice, the better. Okay, so again, I'm going to split screen this so we can do the work on the left-hand side, and anytime we do something, we'll adjust the picture on the right. So first things first, remember we like to factor these, put them in factored form. So we'll have x minus 2 on the top. And then this is a trinomial. Two numbers are multiplied to 6 and add to 5. X plus 3, x plus 2. Step 1, to find the vertical asymptotes. Remember the vertical asymptotes are going to be the values for x. That's going to get you a 0 on the bottom. They can be read pretty easily from these factors. So x plus 3 is going to produce a vertical asymptote of negative 3. And x plus 2 is going to produce a vertical asymptote of negative 2. We're here right now. We'll do our test points. Oh, actually, let's draw the asymptotes on the graph. So they're going to be right close to each other. One of them at negative 3. Oh, sorry, that was at negative 4. I'll just move it over. So one of them at negative 3, and the other one at negative 2. That wasn't very good. I was much better at this before, but luckily I can cheat and just move it over there. I'll give you a second to draw those asymptotes. And then we're going to do the test points. And maybe this might be a good spot to pause the video. Give everyone in class a chance to do the test points. Also give a chance for anyone who's missing this or hasn't seen this before, they can learn about these test points. So maybe we'll pause just for a second, let everyone do the test points. Okay, we're back. So I'm going to do test points on negative 3. So I need something just to the left of negative 3, which is negative 3.1. And just to the right of negative 3 is negative 2.9. I'm going to plug in negative 3.1 into the function. On the top, it's negative 3.1 minus 2, so that's going to go negative. And negative 3.1 plus 3, negative 3.1 plus 3 is not enough to get me into the positive, so it's still going to stay negative. However, negative 3.1 plus 2, same thing, not enough to get me into the positive, so it's going to go negatives. So I have negative divided by negative times negative, so on the bottom is negative times negative, which is positive. And then a negative divided by positive is negative. So that's negative infinity. Now I'm going to do the test points on negative 2.9. Negative 2.9 on the top, minus 2 is going to stay negative. Negative 2.9, and then I'm putting it into this guy here, plus 3. Of course, the plus 3 is big enough to takes it all the way to the positives. But negative 2.9 plus 2, the plus 2 is not big enough to take it to the positive, so it's going to stay at negative. Again, on the bottom, I've got a positive times a negative. That's going to stay negative. And then the negative divided by a negative is positive. So check for your test points on the negative 3 asymptote with your partner. Make sure that you're all on the same page. I'm going to draw that onto my sketch. So just to the left of this asymptote, it's going to go down. And just to the right, it's going to go up. Now we'll do the same test points, except now with negative 2. So just to the left is negative 2.1, and just to the right is negative 1.9. Plug in the numbers again. Negative 2.1 minus 2 is going to stay negative. Negative 2.1 plus 3. The plus 3 is big enough to take it all the way over to the positives. The negative 2.1 plus 2, though that plus 2 is not big enough to take it to the positive, so it's going to stay negative. That's going to result in a negative in the bottom, negative on the top, so this can be plus infinity. Throw in negative 1.9, minus 2 is going to stay negative. Negative 1.9 plus 3 is going to be positive, and negative 1.9 plus 2, that's big enough to take it to the positives. I'll have positive on the bottom. Negative divided by a positive is negative, and I'll have negative infinity. Make those sketches over here. So just to the right, or sorry, just to the left of the asymptote, it goes up. And just to the right of the asymptote, it goes down. So all these are great clues because, you know, we saw one with two asymptotes in example 2, where it started at the top and went to the bottom. This one, apparently, up here, it's at the top, and then somehow it's going to come back to the top. So it might look a little more quadratic than the one we did in example 2. Okay, so there's your vertical asymptotes. Next, we'll take some horizontal asymptote. Again, if you want to pause and give people a second to try this on their own. Okay, so we're back. Here we're going to compare the degree in the top, which is n. In this case, the degree is 1. Degree in the bottom, which is 2. So n is less than m, which means we have an asymptote at y equals 0. When the bigger number's on the bottom, it's going to get really, really small. The bigger that number gets. So we'll be really close to 0. So we're going to draw this asymptote here. Again, you might want to draw it just a little above or a little bit below, just so you can see it, right? Those dashed lines just sort of exaggerate that it's there. But we have an asymptote at y equals 0. Because we have a horizontal asymptote at y equals 0, we can do our test points. We can put in negative infinity and positive infinity. Other asymptotes, it's useless. But here it's not. It will tell us if something is plus or minus, which will allow us to see if it's coming from the bottom or the top. So I'm going to do a test on negative infinity. So I'm going to put negative a bazillion in minus 2 is negative. The plus 3 is not going to change it. It's still going to be really negative. And the plus 2 is not going to change it. It's going to stay negative. So I've got positive on the bottom, negative on the top. So this is going to be a negative number, negative small number. When I put in positive a bazillion, the minus 2 is not going to influence it. It's still going to be positive. The plus 3 just makes it even bigger. And the plus 2 makes it positive even bigger. And so we'll have plus. So this test point only works when y equals 0. Because now it says, when I go off and put something down in the negative, so way to the left, the answer is going to be a negative small number. So it's going to come up like this. And when I put something in the bottom, or sorry, when I put something to the right, really, really big, it appears it's going to come from the top. So this is important because if we had to guess, I might have guessed that since this graph here is coming down to the bottom, I might have guessed that this graph would do this. That would have been my guess. But this tells me that's not true. Okay? So my guess there would be wrong. So I'm just going to erase that. There'll be another clue later on to tell me that that guess would have been wrong. Okay? So I'm pretty comfortable I've done everything right. I'm going to go on and move on to my next stuff, the next clues, which are the intercepts. So I'm going to put in the y-intercepts and the x-intercept. So the y-intercept is when x equals 0. I'm going to plug this into the original function. It's really easy there. So wherever I see an x, I'm going to put in a 0. 0 squared plus 5 times 0 plus 6. So that'll be negative 2 over 6, which is negative 1/3. So it turns out that there's a y-intercept at negative 1/3. So that's on my graph. Negative 1/3 is about here. I might exaggerate a little bit, but it's right there. Next, I'm going to do the x-intercepts. X-intercept is when y equals 0. Again, I'm going to plug it into this function. Set y equals 0. That means that the f at x is 0. X minus 2 over this bottom. And remember, it doesn't matter which form you use because the bottom is going to disappear in a second. Why does it disappear? Well, it's going to come up here and get multiplied by 0. And so it's just going to be 0 equals x minus 2. Solve for x, and I get 2 equals x. So it turns out that there's an x-intercept. So again, maybe a bit of a surprise, because I had an horizontal asymptote at 0, but it turns out that it actually crosses right here. That's allowed. It's allowed to cross horizontal asymptotes locally. At the extremes, in the negative and positive infinity, it might do something else. This is the second clue that my graph before was wrong, because it turns out that the graph actually comes and goes through the negative, or it goes through it too. All right. So that's as much information I have. The rest I've got to draw on from experience. Now, I've drawn lots of these, so I know what's happening here. You haven't drawn a lot. That's why you're watching this one, to gain experience. So here's one thing I know. On the left-hand side, you see that it's going this way and this way. So I'm pretty confident it's going to go something like this. A lot of times that meant that some here it would have done that. Not this case. All the clues none of the clues support that, so that's not right. The clue here that it's down here, and then it comes from the top, and it goes through these 2 points. So it does this. Okay, it actually has this little bump in it. So that one should have gone through negative 1/3, but I kind of missed a bit, but that's okay. But it's going to come through and go through negative 1/3, and then it's got to go through x equals 2, and then it's going to go up a little bit, but then the asymptote's going to pull it down. And so it comes down and it pulls and it gets closer to this. So it results in a little bump. So if you think back to the first day when you were graphing all sorts of these, we saw one with a little bump. Okay, and we'll check this on the graphing calculator to see if that bump's there. That bump, by the way, I'm going to exaggerate. So this bump here, I'm going to exaggerate. The graph probably only goes up a little bit and then comes back down. But I'm going to exaggerate that bump just to show it. Calculus later on will help us figure out how high that bump is, but right now it's just a guess. Okay? And it also shows how important that this clue was and this clue was. Without that, we might have guessed that it just gone here, right? Or through the point and done something like this. But those 2 clues tell me that it actually crosses and makes a bump and then comes back. So I'm just going to erase all that red. Okay? And the last part is this thing in the middle. And the thing in the middle, the one we saw in example 2, behaved like a cubic. Well, that's because it started on the top and ended at the bottom and had an x-intercept. This doesn't. This starts at the top, ends at the top, no x-intercept. So it's going to do like a little quadratic. It's going to do something like this. And then we have our picture. Let's go to the graphing calculator and see what it actually looks like. Ken, you could have these on your, you could be testing this on your own. This is a good thing. Don't push the graph in first before you dry all this sort of stuff. You don't want to get influenced. You want to try and figure out the sketch on your own because you're not going to have the graphing calculator later. All right, so there's the graph. I don't know if everything will be on here, but we'll see. Okay, so we've got the general shapes. We've got that beginning part is the same. The after part's the same. Looks like our scale's too big to see the little or not big enough to see the little parabola. So I'm going to go up here and make this a little bigger. See if I can see that parabola. Still not big enough. I'm going to change my window again, maybe go up to like 30. Oh, there it is. So there's that little parabola up at the top. It's not really a parabola, it just looks like a parabola. Okay, and the other thing that I don't see is the bump. So I'm going to zoom. I'm going to zoom in. I'm going to take my little camera here and I'm going to zoom in somewhere around here. I'm going to zoom in around 2 because I know it crosses at 2. Oh, there it is. I can see that it kind of goes up. Okay, maybe I'll zoom in one more time. No, too close. Okay, so let's change my window. I'm going to go from 0 to 4. I'm going to change this to like negative 0.5, 0.5. Let's see if that can help me. There, I can see it coming up. It crosses. Oh, okay. So I have it coming up there. I'm going to change the window a little bit more to see when it comes back down. So I'm going to go to 8. Let's try that. So there it is coming up. It crosses it too. It goes up. And, oh, still not big enough. Let's go to 15. Maybe we'll see it come back down. So there it goes up. Oh my goodness. It's tragic. Goes up. There we go. It's starting to come back down. Okay, so we have that little bump. Okay, so that's example 3. You should have lots to practice now from the worksheet and any other ones that I've written on the board. And good luck with your practice.